All right, B. We got f of x equal to ax squared plus 10 for x is greater than or equal to 2. And it's going to be x squared minus 6x plus b for x is less than 2. All right, continuity. What's the shortest way we could write this? Could I just go a times 2 squared plus 10 has to equal 2 squared minus 6 times 2 plus b? These are both polynomial functions. The limits are going to exist, right? So we just do a direct substitution of 2 in its both parts. Is that okay? Saves a little bit of writing. Simplify this a little better. We get 4a plus 10 equals, what was that, 4 minus 12, negative 8, plus b. And I like to simplify this a little bit. I'm just going to add this 8 over here, make 18. So I'm going to get 4a plus 18 equals b. I'm going to leave it like that. I'm not going to go any further, okay? We have a solve for b. That's good, okay? So there's our continuity statement. The limit from the left equals limit from the right when x equals 2. Now let's look at our derivative from the left and right. Okay, and I'm going to write this as an equation to start with. The limit as x goes to 2 from the left, which would be f of x is x squared minus 6x plus b, minus f of 2. What is f of 2? Well, that's just going to be 2 squared minus 6 times 2 plus b all over x minus 2. What does this have to equal? The limit as x approaches 2 from the right, which is the derivative from the right. F of x, ax squared plus 10. F of 2, a 2 squared plus 10 all over x minus 2. Okay, now we have the limit. X goes to 2 from the left. Now, it's going to be a little bit of simplification, but that's okay. So that's, what, 4 minus 12. That's negative 8, right? So minus negative 8. And then minus b. All over x minus 2. That has to equal ax squared plus 10 minus, okay, that's going to be 4a and then minus 10 all over x minus 2. Notice we are not moving anything across the equal sign right now. We just know the derivative from the left has equal to the derivative from the right. And we're not bringing anything into these limits. We're not moving stuff around. We're just going to evaluate these limits. We know they have to be equal for this function to be differentiable. Okay, looks like b minus b. And can we factor that numerator, save ourselves a little bit of writing? X squared minus 6x plus 8. X minus what? 4. And then x minus 2? All over x minus 2? If you're kind of like me, you would have already counted, like you already crossed those out. That's a good spot to be in right now. Okay, what do we got here? 10 minus 10? Is that right? Are we good with that? Okay, now we have ax squared minus 4a. I think we got to factor an a out. But then we'll have x squared minus 4. Yep, difference of squares. And right away, we're canceling that out. Okay? Again, if you're doing this correctly for these polynomial functions, this better cancel. Your denominator better cancel. Don't use any math magic, but it better cancel. Okay, after we substitute 2, looks like we get negative 2 on the left side. After we substitute 2, we get a times 4, which is 4a. And then what does a equal then? Well, that's kind of convenient. We have a function solved for b already. Negative half times 4, was that negative 2? And therefore b equals 16. Okay, how we feel about that? All right, not too bad. I think the biggest thing is, what are they looking for? What do I gotta do to set up the problem so we can answer what they're looking for? Okay, when it comes to continuity, it's always a limit from the left equal a limit from the right. Making sure x equals 2 actually, and then making sure your derivative from the left equals the derivative from the right. Okay, part C, I will tell you that a equals 8.